Hello and welcome back to a brand new Armory 3D tutorial. Now in today's episode I'm going to show you how to make your very first game, your very first Flappy Birds game inside of Armory 3D. Now if you're brand new to Armory 3D and haven't really used it, and well, I've got the perfect few episodes for you. I've made 3 episodes about understanding the basic input nodes, action nodes, and basic logic and conditions of Armory3D's nodes and the most commonly used things that you'll use in a game. You can go check out those 3 episodes on my channel. I'll link to them in the description. And once you've followed along with those, then you should be able to come back here and understand everything that happens. Basically, I'm trying not to use any other nodes than the ones I've already covered in those 3 episodes, just to help you guys out. So now we're going to talk about how to make your very first Flappy Birds game inside of Armory 3D. Now it's not going to be exactly Flappy Birds, it's going to be more based on it. I'm going to have a lot more creative freedom because I don't like redoing things that have already been made. So let's go ahead right now and start making it. So we have our camera right here, so we need to set it up. So let's go ahead and grab the center camera to view. Let's press 0 to go into camera view, and let's just move the camera into a good position. Something seemingly like this. So it's not directly in the center, it's slightly offset onto the left hand side. And that seems about good to me. Now let's extrude the focal length out a little bit to give a bit more field of view. And that seems pretty good. Okay. Now that we have our camera set up, we can actually go ahead and add a script to this player. Basically what we want to do is we want to make the player jump up whenever we want it, when we click or when we use the space button. So let's go ahead to the data tab and add a new node tree. This node tree is going to be called jump. But before we do anything, let's just press F2 and rename the cube to be our player. Now let's go to the scripting tab and open up the logic node editor. We can actually select the jump node tree, press N to remove the sidebar, and let's join together these areas because we don't need them. Okay, now what we want to do is we want to actually add a script. So let's go ahead and grab a input. So the input that we're going to use is both a keyboard and a mouse. And what we're going to do is we are actually going to merge these 2 functions together. And so whenever we trigger one of these inputs, the action will be the same. So let's go ahead and grab the merge node and select 2 inputs, and then we can plug these 2 in. Like that. Okay, now what we want to do is we want to apply an impulse on the player so it pushes it up in the positive Z direction. As you can see in our 3D world here, this little gizmo, the Z is pointing upwards because the Z is the 3D view. We've got the X and Y, which is obviously green for the Y and red for the X. And the 3-dimensional axis is the Z axis. So we can go ahead and add an impulse node, apply impulse. The object in question is by default going to be the player, so we don't even need to define it because the script is attached to the player, so by default it's going to look for it and it will find that it's the player. But you know, we can actually just eyedrop the player because why not, it's better to be sure. And now we can actually go ahead and add an impulse. So as you can see, we have a bunch of values. Now the order of the value here is the X, Y and Z axes. So we want to affect the bottom one, the Z axis. And instead of going into the negative values, which is going to bring our player down, we actually want to add a positive, so it's going to bring our player up. Let's set this to 1. Now since we have an impulse which is going to push our player up, we also have to have a counterforce, which in our case is gravity. Now if we go to the scene tab right here, by default we do have a setting called gravity, which is usually already enabled by default, and we can drop this down, and as you can see the default is it's got a drag of minus 9.8, which is I believe the Earth's correct gravitational pull. So we can actually change this to be something like minus 15, something a little bit stronger. Now we can go ahead and actually play this game to see what our different what the pull and impulse look like. And as you can see, it's not working. The reason being because my stupid pea-brain has forgotten to add a rigid body. So let's select the player, the cube, and go to the physics tab and add a rigid body. Set to active and add the collision box to be a box because it's a cube. Now we can go back and watch the player fall, and by pressing space or left clicking you'll be able to apply the impulse. And there we go. Now by clicking the space bar or by clicking with the mouse, you will add an impulse to the player and stop it from falling all the way down. So there we go. Now we have a control for the player. We actually need to generate and move the platforms, the pillars, to be able to navigate the player through those pillars. Now first thing we're going to do is we're going to add those pillars. So let's press 1 on the numpad to go into side view, and let's go ahead and add a cube. We can move this cube out on the x-axis. I'm going to move it out to about 10 on the x-axis. As you can see, we're about 10. And now we can actually just scale it up on the z-axis, as in on the upwards axis. And let's go into edit mode by pressing tab. We can select all of the meshes, mesh, and press Shift D while in edit mode, and we can bring the top part up, this part that we just duplicated. And there we go. Now we have a pillar looking object. However, the origin is actually on the bottom pillar, which is the one that we originally had. So we need to set the origin to be in the center. If not, our spawning system won't work very well. So first of all, let's actually press Ctrl A and apply the rotation and scale and apply the location. And as you can see, we have the origin that has disappeared. So let's go to Object, Set Origin, Origin to Geometry. And that's going to pinpoint the origin of our object to be in the center. So now when we move it, it's all centered around the origin. It's the center of the object. So now let's go ahead and add a rigid body to the pillar to detect collisions as well. So let's go ahead and set it to passive, because we don't actually want this one to be affected by gravity. We don't want it to fall down. And the collision shape isn't going to be box, because we actually have two separate objects. So we want the physics to calculate the actual geometry instead of just the approximate mesh. So for the collision option, let's set it to mesh, so it's going to calculate each face individually. And that's what we want, so we can actually have the player pass through here. Now that we have that set up, we actually want to add a script to make the object move towards the player. So obviously on the minus x axis. So let's go ahead and in the scene tab, we're going to add a new trait that we're going to call. We're going to add a new node tree that we're going to call level. And we're going to use that to actually generate the level procedurally, because we're going to start duplicating the object procedurally. So basically it's the computer that's going to decide what the level is going to look like, with some parameters that we're going to give it. But we also want a script to be applied to each of those procedurally made objects, those procedurally made pillars, telling them that they need to move forwards. So let's go ahead in the Object Data tab and add a new script as well, that we're going to call pillar, like that. And we can go to the scripting tab. So we now have two different node trees. We have the pillar and the level. So let's start with the pillar, the most simplest. We just want the object in question to move forwards. However, like I said, we're going to procedurally generate them. So we can't define the object in question to just move forwards. We have to apply it to all of them. So how we're going to do that is basically we're going to grab an on update. So every single frame, something's going to happen, and that something is going to be moving the object on the negative x-axis. So let's go ahead and grab a translate object right here. And as I explained previously, you can't actually just define the object in question because we are going to have multiple objects and we want them all to have this same script. We're going to have multiple objects all inheriting this same node tree. So let's go ahead and grab the self object. So basically it's going to look for whatever object is the owner of this node tree right here. And even if there are multiple objects, for example this one and this one both have it, it's going to look at what object has the actual node tree and it's going to apply it to it. So even if there are multiple objects, for example right now, it's still going to be able to affect both of them using the same script. So you don't need to make like hundreds of different scripts if you have hundreds of different objects. It's basically like a module that you're going to call for each object. So let's go ahead now and add a movement to this, because yes, we have a translate node, but we actually have to input a value. So like I said, on the negative x-axis, so let's go ahead and set it to maybe 0.060. Let's go ahead and check out if that speed is suitable or not. And as you can see, we have actually set it to be the wrong axis. Yeah, I set it on the y-axis, so it's moving actually towards us. So let's go ahead and actually set it minus 0.60 on the x-axis this time, because the axes go x, y, and z, as you would pronounce them naturally. Well, at least as I do. That's how a lot of people do, and that's how you order them. That's how they are ordered. And as you can see, that is way too fast because I forgot the 0 in front. Yeah, we have small increments here because if not, as you can see, it will go extremely fast, way too fast for anybody to be able to play the game. And as you can see, we have a good little level going on here. So now what we want to do is we actually want to generate different platforms, and that's why we have our level script. So let's go ahead in the level script and add a onTimer event. Now I spoke about the onTimer event in my previous tutorial about inputs. So let's go ahead and grab the onTimer event. There we go. Let's set it to repeat because we want this level to be constantly generated. We don't want to generate just one extra piece. And set it to maybe 3.5. That seems like a good value. Now let's go ahead and add a spawn node. So let's write a spawn object. The object in question is going to be the actual level, the cube, and we actually want to add a location to where that object is going to be spawned. So let's go ahead and add a transform node. Now we actually want to use just the location. We don't want to change the rotation or the scale. Now this is where Armory's colored sockets come in very handy, because we want to use a float to add a random number, a random location to the object every single on timer, as in every single time the timer is repeated. So what we're going to do is we want to add like I said, a random time. So let's go ahead and grab the random float. Now as you can see, we have a gray output socket and it feeding into a purple socket. So what we want to do is we basically want to convert the gray output into the purple. So what we're going to do is we're going to grab a vector and plug the purple vector into the location. And as you can see, now we have a bunch of different options and they're both gray. So we basically converted the basic location through a vector so we can add a float. So if you're not very good at programming, you just have to look at the colors and you should understand perfectly. And obviously, let me just explain what we're doing here. We're basically every single 3.5 seconds, we're spawning this object at the location of this. Right now we haven't added any. Right now we don't actually have any values of where to spawn it, and we're adding a random location as well. So first of all, which is why I was moving this out to about 10, the location of about 10 on the x-axis. That is because we actually need to input 10. Because if we don't, it's going to spawn at 0, and 0 is in the center. And that's where the player resides. So basically every 3 seconds it will spawn a platform on the player. And we don't want that, we want to spawn it in front. Which is why I added the platform here. Now the x-axis is moving towards the camera or away from the camera. We don't want to do anything with that, so let's not change it at all. And the z-axis is the one that moves the object up or down. And this is the one that we want to randomize. And that's why we imported this random float node. So let's plug the grey into the grey here. And obviously it's very easy to use. You have a minimum value and a maximum value. So the minimum value let's set to -5. Obviously value wise you can actually just move the platform itself to look at where -5 would be. -5 is down actually, -5 as you can see there. Go into camera view. Let's actually just go back to full screen. -5 is the actual limit that the platform can go to, because there it's barely actually coming out, and that's -5. Now if we move it up, the maximum value that the platform can go without being out of frame is about 5. And that is the maximum that the platforms can actually go, so that is the minimum and maximum, -5 and 5. Now let's go ahead and actually just play this game to see if everything is working correctly. Now obviously because of the scale of your game, these values might not be the same. You just have to test them out. And there we go, we have a procedural generation happening as you can see. However, our physics are interfering with the platform. But the important thing is the platform has a procedural generation. Now since we have set this value to be a every 3.5 seconds, the distance between the two platforms are quite high. Also we set it to be a to spawn the platform at a location of 10 on the x-axis, so that's moving the platforms away from each other quite a bit as well. So we can actually reduce this to maybe about 3 or even 2.7 maybe, and we can actually try that again. And as you can see, we do have a good platform generation going on here. Okay, now everything is working fine and the platforms are a bit closer together. You can always like move this value to be small if you want, but I'm gonna keep it as is. So what we want to do now is we want to deal with the player's collisions, because when I collided earlier, the player just started spinning around and whatever, did some random stuff. So I actually want to add a bad thing. I want to actually make it bad for when the player collides with the platform, like in Flappy Birds, where the bird just nosedives into the ground. So what we're going to do now is let's go over to the player, and let's not go to the player because we want the script to be attached to the actual levels. So like I did on the previous node tree, like here, we added the self node. So let's just continue with this node tree, and let's go ahead and grab a on contact node, and this on contact node is going to be using the self value, which is going to apply just like it did the movement to the generated platforms. It's going to apply this physics collider checker to all of those created platforms as well, and it's going to check if the player is colliding with the platform, and if the player is colliding with the platform, it's going to remove the object being the player. And then yeah, that's pretty much it for now. So at least the player won't be moving. Now obviously the platforms will continue moving, but that's just my artistic choice. I like to keep the platform still moving, and when we add score later on and player removes, the score will stop as well, and this would be the page where the high score and the current score shows up. So let's go ahead and add in some color, because I think the scene is a bit boring. So let's go ahead to the shading tab and go ahead down here and set this to be a nice little blue color. And for the platforms, let's add a new color, call it pillars, and set it to be a scary orangey red color. We can augment the specular to have them stand out a bit more, and then we are pretty much ready to add some more interesting things. However, due to the length of this tutorial already, I'm afraid I'm going to have to pack everything into a part 2. Sorry to disappoint you, but today we have accomplished a lot. We have added procedural platform generation. I've explained it as best as I can. We also had merge inputs with the player, and we added a player impulse system. So I think altogether it's not bad, and I hope you enjoyed the tutorial. I hope you understood and are able to follow along without any problem. If you do have any problems, then leave a comment down below. I'll do my best to answer. So thank you very much for watching, and I'll see you in part 2, and make sure to check out my shorts channel where I showcase different video game ideas to help creators overcome that creative block. That's it from me, till next time.